Hello and welcome back to Mr. Powers Teaches Algebra. So we did in our last video, we did some of properties of logs, and we talked about what log base e is and natural log that is, and the common log base 10. Now I want to do a few more properties of logs we're going to find useful. So before we do that, recall quickly our definition for logs right here. Y equals log base b of x is equivalent to b to the y equals x. In fact, let's make that a little bigger. Okay, and then I got, maybe not. There we go. And then I have the properties of logs we went over last time, right here. So log of 1 is 0, log base b of b is 1, log base b of x is x, or log base b of b to the f of x, so any function of x up here will equal the function of x, and b to log base b of x equals x. And really that's showing that the property of it being an inverse. Logs are inverses of exponents, exponents inverses of logs. They undo each other. So keeping that in mind, we got 4 more properties. 8 is, well, I talked about a little bit last time, and I used this to kind of explain this one a little bit. And we haven't gotten to look at the graph yet that much of these and really see, but the fact that exponentials are 1 to 1, their inverses are functions as well. We have this property here for number 8. Okay? If the log of something equals the log of something else, well, then those two things must have been the same. That's what it's saying here. And that's very useful when we get to solving equations, is this. So, without further ado, these are the properties. I want to prove them, though. So, really quickly, log base b of x times y is log base b of x plus log base b of y. So, this product, you can rewrite as a single log of a product, you can write as a sum of 2 logs. Similarly, we have a quotient rule. The log of a quotient you can write as a difference. Log of the top minus log of the bottom. That's very, very cool. All right. And then we got this one. And really, 7 is just an extension of 5 in a way. Hold on. Okay. Yeah, 7 is just an extension of 5, and then we talked about 8. So I'm going to prove 5. I'm going to prove 7. I want to go over those 6. I'll leave as an exercise for you if you are really that interested in it. Look at this. This white shirt's not so good with the. Yeah, well, I have a floating head today. All right. So anyway. Is it the white in the white background? I think that's what it is. Anyway, here, hold on. Let's see if I can fix it. There we go. I apologize. Moving on. Okay, so let's prove this guy. So I was playing around with this, and I think the way I want to do this, I'll do this off to the side here. So property 5, we're going to go ahead and prove. So what I'm going to do is I'm just going to say, you know what? We're trying to prove property 5 here, a product property for logs. I'm going to say let log base b of x equal u and log base b of y equal v. And if that's the case, then using our definition for logs, we can say b to the u equals x and b to the v equals y. All right. So now if we have those two things, and vice versa, really, I could start with this and go back and say, well, then this is true. Okay. So now what I'd have is I can rewrite my log. So let's go ahead and say now I can write that log base b of x times y is really, hold on a second, log base b of x times y is really going to be log base b of, so let's replace the x and the y with these guys, b to the u times b to the v. In which case, now I can say, well, that's really log base b of, well, b to the u times b to the v. I can write that as a single exponent using properties of exponents, b to the u plus v. There we go. Now, if that's the case, then let's see, we're trying to get this. We're trying to get log base b of x plus log base b of y. So let's say I want to make this, oh, well then, no, there it is. Log base b of b to the u plus v. Using our property here, property 3, we have simply u plus v. There it is. And then what was u again? What was v? U is log base b of x. V is log base b of y. We're done. Log base b of x plus log base b of y. So there is our explanation or proof of property 5. So it's a very neat little proof there. Similarly, if you want to on your own, you can make a very, very similar proof for property 6 here, or the quotient property. So I'm going to leave that to you if you're really interested. So let's take this, move this over, and then I want to talk about that property of 7. I want to do that one now with you guys. So I'm just going to slide that over. Whoop, right there. There we go. And now let's go ahead and look at property 7. Okay. So the way I'm going to do that one, this one's very easy. So log base b of x to the r is really the same as log base b of, you know what? Yeah, let's change the color on that. Or the blue might be a little too close to that blue. One more time. Here we go. There we go. Let's make it the dark blue. Oh, that doesn't work anymore. How much fun is that? Hold on. All right. So log base b of x to the r is really just log base b of x times x times x times x times dot 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 times x. And how many x's are there? There's r of them. So we got r times, we could say. Right? Well, I know if it's just, say, if it was x times x, right? As a particular case, an extension of property 5, we could say, log base b of x times x is log base b of x plus log base b of x. What is that? That's really 2 times log base b of x. So we can see it working there for 2 x's. Would it work for 3? Sure. Why not? We can just extend this rule. We can use property 5 over and over again as many times as we want. And then we got this sum of all these logs of the same thing. That's really what's going on here. And there's our explanation for this. And this is a very handy property. So I could rewrite this then as log base b of x plus log base b of x plus log base b of x plus dot 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 plus log base b of x. And how many of those do I have? we got R of those. R times. Lots of those. All right. So, well, what's a shortcut for repeated addition? I believe it's called multiplication. We got R of these we're adding together. That's really just R times log base B of X. So there's our explanation for this. Okay. And that's all I think I really needed to show in this video for you guys. So right about 11 minutes. Guess that's how long these videos are going to take. I hope you found it useful, and until next time, enjoy doing math.